Hello friends, my name is Lalit Singh Mehta and today I am going to explain you the concept of Poisson's ratio. So before going into Poisson's ratio, we have to understand the types of strain. So there are two types of strain basically. The first type of strain is called as the primary strain and the second type of strain is called as the secondary strain. This primary strain is also called as linear or longitudinal strain, and this secondary strain is also called as lateral strain. Now first we will see what do you mean by primary, linear or longitudinal strain. So now suppose there is a body with length L and it is being acted by an axial tensile load. So under this axial tensile load, the length of the body tends to increase or expand. Let this dimension increase in length is denoted by delta L. So this primary, linear or longitudinal strain, which we can denote by E with the symbol E, is nothing but change in length upon original length. So this change in length in our figure is delta L and the original length is L. So this is nothing but primary, linear or longitudinal strain, because the major or the primary strain which will be coming on this body under the action of this axial tensile load is on length, is on dimension length. That's why it is also called as linear or longitudinal strain. So this is all about primary, linear or longitudinal strain. Now we will see what do you mean by secondary or lateral strain. Suppose I draw the FBD of this figure, or we can see the 3D diagram for this figure. So this is the bar. So now we can see, suppose this load P is acted on this bar like this, and this is L. So this length is the primary dimension, we can see. But what about this width and this thickness? This width and thickness are called as lateral dimensions. Lateral dimensions. So under the effect of this tensile axial load, there will also be changes in the lateral dimensions like width and thickness, and this change in lateral dimension is shown by secondary or lateral strain. So suppose lateral strain is denoted by E lateral. So it will be lateral dimensions are width and thickness. So change in width upon original width, or I can say it as delta B upon B. Correct? Similarly, lateral dimension can be for thickness. So E lat can be change in thickness upon original thickness. So these two are examples of secondary or lateral strain. Got it? And this, when the change in the dimension length takes place, then the strain produced is called as linear, primary or longitudinal strain. And when the same load is applied and the lateral dimensions, change in lateral dimensions are being observed, then the corresponding strain is called as lateral strain. So these two, B, change in width and change in thickness, are the example of lateral strain, and this length, change in length, are the example of linear strain or primary strain. Suppose I will take another example. Let's see another example of lateral strain. Suppose there is a cylindrical rod and it is being acted by a axial tensile load, and the diameter of rod is equal to d, and we have the length for this. So the primary or linear or longitudinal strain for this rod will be delta L by L. There will be some elongation of the length, so that will be change in length upon original length, and E lateral for this rod will be delta D by D, change in diameter by original diameter. So secondary or lateral strain is nothing but it is the ratio of change in lateral dimensions, and primary or linear or longitudinal strain is nothing but it is the change in length or longitudinal dimension, correct? So this is the basic difference between primary and secondary strain. Now there is a term called as Poisson's ratio, which connects Poisson's ratio denoted by mu or 1 by small m, is the ratio which connects the two strain. It is the ratio of lateral strain upon linear strain. So if I denote this, it can be E lat upon E. So by using this relation, we can also calculate the changes in lateral dimensions. So Poisson's gave us this ratio to relate the lateral strain with linear strain. So we can find different types of changes in lateral dimensions or linear dimensions by using this Poisson's ratio, and it relates both. For example, again I will take the example of this circular rod. D is the dia. So here E lat example is delta D by D, and linear strain delta L by L. So mu, which is equal to 1 by m, in this case is delta D by D upon delta L by L. So this is all about Poisson's ratio. Hope you like the lecture. Thank you.